Good day, everyone. My name is Philip Usih, and I'll be presenting my project for operating system, which is on traffic management system. The project focuses on implementing and evaluating the concept of deadlock, which consists of resource allocation graph and deadlock avoidance as a safety algorithm in real life environment. I provided flowcharts on each algorithm, the provided output, and the coded interface. The project aims to imitate real life systems using these algorithms to further deepen the understanding of both students and lecturers. Traffic management is a critical aspect of urban planning and transportation systems aimed at ensuring the efficiency and safe movement of vehicles on road network. However, in densely populated areas with complex intersections, the in, with complex intersections, the occurrence of traffic deadlock can severely disrupt the flow of vehicles and lead to congestion. Deadlock in traffic management occurs when vehicles from different road lanes reach an intersection simultaneously and are unable to proceed due to conflicting movements. This report presents the focus. Fo- this repre- this report presents a project that focuses on implementing and evaluating a traffic management system utilizing the concept of deadlock avoidance to enhance the efficiency of traffic flow at intersections. The problem at hand involves the occurrence of deadlock phenomena in operating system and the need to find a solution to avoid deadlocks in both operating system processes and traffic management system. Deadlock refers to a state where processes or vehicles are unable to proceed due to secular dependency or resource conflict. This deadlock issue can be analogous to traffic congestion in real life traffic management. The objective is to identify strategies and mechanisms that can prevent or resolve deadlock in operating system and implement a similar solution in traffic management systems to alleviate traffic congestion. The goal is to develop techniques that ensure efficiency and smooth operation of both operating system and traffic system, eliminating the deadlock state and enabling continuous progress of processes and vehicles. There are four conditions of deadlock which can arise if conditions are held simultaneously. First, mutual exclusion. Only one vehicle can occupy a specific section of the road at a time. In this case, it means that only one vehicle can pass through a traffic signal at a time. Hold and wait. Secondly, hold and wait. Vehicles that reach the intersection hold their position and wait for the traffic signal to change. They do not release the section of the road they occupy until they pass through the signal. Thirdly, no preemption. Once a vehicle enters a section of the road, it cannot be forcibly removed or preempted by another vehicle. It can only move forward when the traffic signal permits. Fourthly, circular wait. Vehicles are waiting for signals in a circular manner. For example, vehicles on road A are waiting for road B to clear, while vehicles on road B are waiting for road A to clear, just like in my code I previously ran it. Then we have deadlock avoidance. There are some deadlock avoidance principles from operating systems that can be applied in traffic management scenarios. Firstly, efficient resource allocation allocates road resources efficiently, effectively, plan traffic flow patterns, and optimize signal timings to prevent congestion. Real-time traffic monitoring uses sensors and algorithms to monitor traffic conditions, detect congestion, and identify potential deadlock situations. Thirdly, dynamic traffic control employs adaptive systems to adjust signal timings and lane priorities based on real-time traffic congestion, avoiding prolonged congestion. Fourthly, conditional as coordination and synchronization enables synchronized signal changes, coordinates intersections and lanes, and facilitates efficient vehicle movement to prevent conflicts and congestion. Then methodology, project management. I manage the project, hardware and software requirements. I used my laptop and programming language was C++. Task distributed. I did the project on my own. A solo project. It was actually meant to be a team project, but it's my individual project. I took care of developing the real-time program for traffic management system. I also crafted the time-lapse program for the traffic management system. I, I also dev- I also led in the development of resource allocation graph and creating informative slides for the project. I also took charge of visualizing the traffic management system, which involved designing and implementing graphical representation for both the algorithms and the overall system view. Mm, so design and implementation. Lane A traffic, lane B traffic, lane D traffic, lane C traffic. In this diagram here, cars in traffic lane A are using the intersection resource dependency, while cars in traffic lane B, C, and D are waiting to enter the intersection processes because lane A now is being used, and as you can see, lane B, C, D cannot use the intersection, and lane B, C, D are requesting to enter the intersection. The traffic in the lanes won't be allowed to enter the intersection until lane A traffic is released first. The traffic management system in this project manages delegation of traffic in lane A to D to ensure intersection, which in this case is the resource. To implement deadlock avoidance principle in the context of traffic management, I chose to focus on dynamic traffic control. This approach involves adjusting traffic signal timings and lane priorities in real time based on the current traffic condition. The traffic management system consists of four main functions that illustrate the use of deadlock avoidance through priority. Firstly, generate traffic. As you can see, this is a image of the the road and the intersection. Like now, lane A, lane B, lane C, lane D. These are the traffic lights. This is the intersection. This function is invoked every few seconds and allows running. It will simulate the lane condition by adding a random value between 1 to 5 cars into the lane. The maximum number of cars in each lane is 25 cars. Detect traffic. This function invoked after every signal operation is complete. It will check the value of cars for every lane and set the priority based on the number of cars. The lane with the most cars will be prioritized over the other lanes with few cars. If there are lanes with an equal number of cars, it will follow the lane order: lane A, B, C, D. This is set signal, which is the third one. Set signal lane. This function is invoked after detect traffic. It will switch the traffic light of most prioritized lane to green, allowing the cars to exit the lane, then invoke handle traffic lane. The handle traffic lane, like the previous one, this detect traffic. Set signal has the the lane as its variable. Also, handle traffic has lane as a variable. For this function, the given lane removes one car every second from the given lane until it's empty, or 15 cars have left the lane, then invoke detect traffic. This is just a example of the test I did by myself. Um, if this shows the output of dynamic traffic control through a time-lapse representation. The figure consists of 5 columns representing the traffic signals and 4 lanes of traffic. Each lane is further divided into 2 sub-columns indicating the number of traffic and the priority P of each lane. In this scenario, the number of traffic in each lane increases randomly between 1 to 5 vehicles every 5 seconds. The priority P is determined based on the number of traffic in each lane. The system classifies the arrangement of priority, with the lane having the highest number of traffic being assigned the first priority. The lanes are prioritized to manage the traffic effectively. The lane with the highest priority has the ability to reduce traffic by allowing the cars to leave the lane for a duration of 15 seconds. This helps alleviate congestion in the lane with the highest traffic volume. The system continues to run until the lane reaches zero traffic, indicating that all vehicles have cleared the lanes and the traffic flow has been optimized. In conclusion, the traffic management system developed in this project offers a comprehensive solution for effective management traffic and mitigating congestion. By implementing algorithms and real-time monitoring, the system effectively optimizes traffic flow and enhances the overall transportation experience. The combination of real-time data analysis, resource allocation, and visualization provides valuable insights for traffic control authorities and enables proactive decision making to alleviate congestion hotspots and, most importantly, avoid traffic deadlock completely. I extend my gratitude to Dr. Fahana Binti Mokhtar for her invaluable teaching and guidance through the course. Her expertise and support have been instrumental in shaping our understanding of the subject matter. And these are my references, and this is just an example, not an example, I mean, this is the code attached to my report. So here we have in Visual Studio, we have my C++ of time-lapse for the traffic management system. As you can see, lane A, lane B, lane C, lane D, all have been assigned the value 0. So this is my code, and my priority lanes, my priorities, all assigned 0. This, after this function here, this will be updated by detect traffic function. So this function is used to handle traffic, discrement integer. Then we have detect traffic function, and as you can see, priority lane A, priority lane B, priority lane C, priority lane D. Also, with our for loop and our if, our conditional statements being implemented for the traffic management system. This displays data 16 values, 16.8. Handle traffic has maximum index variable. This generates random numbers for our traffic management system. It's just to give like a real life example of how busy a road can be during the day, just randomly. It's just random. Then this is generate traffic function with our while loop, which is true, and implement we have our random numbers being set into our various lanes to give the real feel of traffic. That means like the random numbers are just like numbers of cars in each lane, just like an example. Then we have our set signal, with our lane index. Like I already said, it takes the lane variable, and inside it has the handle traffic. And our main function, this is gonna be how it's gonna look like: time, priority, like that. Lane A, lane B, lane C, lane D. This is the main function. So now let me run the code. Oh, okay, let me run. So let me run the code. So now we can see lane C, time 40 seconds, two cars, like that. This is just how the traffic is. And as you can see, it takes time because in real life you have to allow some cars to first go before some cars can move. Lane C, lane A, lane C. This signal shows lane C, time 14. In lane A, two cars, like that. So right now, this is the end, and this is just a preview of this signal as the traffic light, which signaled lane C, which 15 and past one car, and we have lane A to be the next based on priority. So that's it. Thank you.